Okay, factored form of a quadratic function and standard form. We have here f of x is equal to 4x times x plus 3. So this is the factored form of a quadratic function. Of course, one of the intercept is a 0. That's why they didn't write x minus 0 times x plus 3. And its standard form is 4x square plus 12x. Okay. Now the second example is f of x is equal to x plus 5 times x minus 2. And the same thing in the standard form is f of x is equal to x square plus 3x minus 10. Okay. Now, how do you do this? How do you get from this factored to standard form? It is obtained by multiplying. Converting from factored to standard form requires that you multiply the polynomials. Here precisely a binomial is multiplied with a binomial to give this polynomial, right? And this multiplication is done by a process called as distributive property. So here the distributive property of multiplication over addition. What does it mean? We have for all real numbers a, b and c, we have here a times b plus c. A times b plus c is equal to ab times ac. For example, like if I have x multiply with x plus 3, so how do you do that? I have to take like a times b, and then how they did a times c? Same way, x is multiplied with this x times x, there is a plus, I'll have a plus, and x times 3, so to give you x times x square plus x times 3, x3 we say, but it's always we write the constant factor first, so I'll just write 3x, x times 3 is 3x. Okay, that is, in this multiplication of polynomials, what you do is, in other words, when you multiply, to multiply one polynomial times another, you simply multiply every term of one polynomial times every term in the other. Like each value of the first is multiplied with the other. Like here I did x is multiplied with both x and 3. Same way, if you go up there, x plus 5 should be multiplied with everything inside the next parenthesis, that is x minus 2. We are going to see it in a minute. Now, what do you have? When you use distributive property to write an expression that is the product of polynomials as sum of terms forming a single polynomial, that is, two factors together on multiplication will end up as a single product, a single polynomial. Like when you multiply two numbers, 5 times 6. What is 5 times 6? It is 30, a single. It's a product. So a polynomial will also be obtained by multiplying those two terms by making use of distributive. Alright, let us use distributive property to multiply 4x with x plus 3. That is 4x times x plus 3. So how do you multiply this? 4x, this 4 x's will be multiplied with x. Find the product of these two, then the product of those two, right? So I'll write 4x times x, and there is a plus here. Write down plus 4x times 3. 4x times 3. That is 4x times x gives you 4x square plus 4x times 3. 4 times 3, I have to multiply the numbers first. 4 times 3, that is 12, and you have x 12x. So your product is 4x square plus 12x. Let me clarify here. How did you get 4x times 3 is equal to 12x? 4x, just now we have seen that 4 times x is 4x. I think the previous example, 4x is 4 times x, again times 3 I have. So multiply this in numerical factors first. 4 times 3 is 12 and x is a variable that just follows 12x, right? It's very easy. So the product of 4x times x plus 3 is 4x square plus 12x. Okay, then that's what we have there. Let me show you. 4x square plus 12x. 4x times x plus 3 is 4x square plus 12x. Alright, now the same product, the same multiplication, we are going to do it by making use of area model, right? In this area model, what we have here is, let us say, this is a big rectangle, right? And the rectangle, I have one separating line also. So let me take this as x, and this is 3. This length from this point all the way up to the line, it is x, its measure is x, and the next measure is 3. And what is the measure of this vertical line, or the width, is 4x. Okay, the whole line here, this from this point to there, how much? It is x plus 3, and the width is 4x. Alright, so very simple. Now that big rectangle is divided into 2 rectangles. One rectangle here, this is the first one, and that is the second rectangle. Alright, now what is the area of this rectangle? How do you find the area of a rectangle? The formula for finding the area of a rectangle is length times width, right? So now if I assume that for this rectangle, smaller rectangle, the length is 4x and the width is x, 4x times x, that is length times width, is equal to 4x square. That is the area of this rectangle. Okay. Now, second part, what is the area of the second rectangle? Again, the length times width. My length is 4x times this width. 3 is from this point to there. So 4x times 3. 4x times 3 is how much? It is 12x. Alright. And what is the length and width of the whole big rectangle? It is 4x times the whole of this length. That is x plus 3. The area of the whole of this rectangle. So I can write the whole area of the whole rectangle as 4x times x plus 3. Right? That covers this whole thing. Alright. It covers this whole of this thing. That is the area of this whole rectangle. It is same as the sum of this small rectangle and the second smaller rectangle. Right? So this is equal to, what is the area of the first rectangle? That is 4x square plus area of the second rectangle is 12x. So this is just the same product, the one we had just now. 4x square plus 12x. 4x times x plus 3 is equal to 4x plus 12x. Right? So some students, they get it very easily like this. By making use of area model, just break it down. If you have two terms, separate it like this, and there I have a single term, and just multiplied 4x times x, 4x square, 4x times 3 is 12x. Now 4x square plus 12x is nothing but 4x times x plus 3, right? That is the product, and you are proving it by making use of the area model. And if you have two terms in this x plus 4 times x plus 3 we have, and you are asked to draw an area model to represent this product. So let us draw. Right, we have one rectangle, and let me draw a line separating this and another horizontal line. X plus 4, let me call this as x plus 4, and x plus 3. Okay, this is x and that is 4. The distance from this corner to that line is x, and next x plus 4, this second part. Similarly, this side I have x is this piece, and from there it is 3. And on the whole, this whole length is how much? X plus 4. And this side on my left here, that is the width, is how much? It is x plus 3. Okay, you have x plus 3 is this total thing, and x plus 4 is the other one. Alright, now the big rectangle is divided into how many parts? 1, 2, 3, 4 parts. To find the area of the whole of this rectangle, I can just multiply length times width. That is x plus 3 times x plus 4, or x plus 4 times x plus 3. The same thing. Right? Multiplication is commutative. I can just write it down either way. And so the product of those two, big length and big width, or sum of the areas of this first rectangle plus second, the third, and the fourth. By adding all the 4 areas also, we get the same answer. It has to be the same, right? 4 pieces put together, a big piece, a big rectangle. All right. So let us multiply. Let us find the areas of each one of these. Okay, the first one, here it is x times x. What is x times x? Gives you x square. X multiplied with x is x square. Then you have, for this rectangle, the length, say you know that this is x only. If this line is x, the side, the other one, this also has to be x. And x is multiplied with how much? This 4. 4 is that length. So x times 4 gives you 4x. I did x times 4 to get 4x. This is there. Now the third rectangle, the third piece here, 3, and what is this one? 3 and x. So 3 times x gave you 3x. I'll put it here. 3 times x is 3x. And the last rectangle, this value, that length is 3, and the other one is 4. So 3 times 4 is how much? 12. 3 times 4 gave you 12. So these 4 are the areas of the 4 pieces, right? The area of the first piece is x squared. The area of the second piece is 4x. Then the third one is 3x. And you have 12 as the fourth one, right? So you have the area model and you did the multiplication. Now using that, using our area model, I'll write the equation with the product of the two binomials on the left side of the equation and equivalent polynomial on the right. Okay, that is the bigger one, x plus 3 times x plus 4. On the top I have x plus 4, right? X plus 3 times x plus 4. X plus 3 times x plus 4, or you can even have x plus 4 times x plus 3. It is just the same. I'll write x plus 3 times x plus 4 is equal to, right, this is a big rectangle, is equal to, first piece is how much? The area of the first piece is x squared. The area of the second is 4x. Then I have 3x, the third one, and the fourth is a 12. Okay, can we simplify this further? Yeah, we don't like to leave it these two like terms separately. Just put them together, and left hand side remains the same. X plus 3 multiplied with x plus 4. So the product of these two binomials is x square plus 4x plus 3x. To 4x's add 3x's to give 7x. 4 plus 3 is 7, and the constant is 12. Right? That's all. This is the answer. This is the product obtained by multiplication of those two binomials. And here, what is the thing we used? We made use of the area model. Okay, so you please try problems of this type. Okay, thank you.